Okay, so we're on example 5B. We did 5A in class. 5B, if I'm approaching 5, my numerator obviously is 0. If I'm approaching 5, my denominator, this is 5 plus 4 is 9. Square root of 9 is 3. 3 minus 3 is 0. 0 over 0. Away we go. All right, so we have to do the uh, multiplying by the conjugate thing. Let's go that ugly color right there. And so let's multiply top and bottom by 3 plus the square root of x plus 4. And denominator, 3 plus the square root of x plus 4. Now, recall when we did one like this in class, the part where you're actually multiplying the conjugates is pretty cool. But then the part where you're not, don't actually multiply those together because the x minus 5 is going to cancel. Okay, so let's take a look at that. So you don't want to distribute and just have to factor it back out. So let's leave that be. So we have as x approaches 5. This is what I was talking about. Leave that numerator just like this. X minus 5. And you're like, this is gross. Well, it's not going to be too bad because, like I said, the x minus 5 is going to cancel out. And if something happens where it doesn't, we made a mistake. So hopefully we didn't. Okay, didn't do that. All right. And denominator then is going to be 9, right? And I don't have to do the outside and the inside of the FOIL method, if that's what you did. I think most of you said you did, that because those are going to cancel out. I have a 3 times the square root of x plus 4 and another 3 times the square root of x plus 4 with a subtraction. They cancel out. But I have to be careful here because I am subtracting. I'll go ahead and show it. I am subtracting x plus 4 because the square root of x plus 4 and square root of x plus 4 multiply together is going to be x plus 4. All right, so there we are. And if you look there, oh gosh, that one's a little tricky, but it's going to work out just fine though. All right, so here we go. That denominator, I'm rewriting. I'm leaving the numerator as is. Okay, so I might be over explaining here, but that's better than the alternative. So x approaches 5. Okay, let me get all this stuff going again. And then denominator now is weird. You're like, no, it's not exactly right. So it's going to be 9 minus x minus 4. Well, 9 minus 4 is 5. I got 5 minus x. You're like, no, it's not the same. But it's opposite. And so they do cancel. But if I were to divide those two out, you were left with a -1. I mean, they're opposites of each other. X, that positive x became negative. The -5 becomes positive. Those are opposites. So if you did cancel out, you could factor out a -1 and switch that around. But I kind of prefer just saying, hey, look, all right, if I do, since those are opposites, if I cancel those out, I'm left with a -1. Okay, which is going to get multiplied, of course. All right. Okay. So now that your 0 over 0 is gone, but it left you with a -1. All right. So that's a little tricky, but that's okay. So now I'm going to drop the limit notation. I'm going to substitute in. So it's going to be -1, the -1 that I created by, and you're like, you don't really need that, but I know, I know what you're saying. And then so 3 plus the square root of 9, which is, I'll just show it, 5 plus 4. This is a good one. And then, All right, and so what do I have? I have the opposite of 3 plus the square root of 9. -6. Nice. Nice.